This question is also from projectile motion. It is also based on the concept that we can consider a 2D projectile motion is a superimposition of two 1D motions along x-axis and along y-axis. So you can read through the problem statement once. Diagram was not given in the question. I am drawing the diagram now. So it is given that the initial velocity is 50 meter per second and it is thrown at an angle of 37 degree. So if I assume that the wall was not present, then the trajectory would have been something like this. Now the wall is kept at 80 meter distance. Now for drawing the diagram, you can calculate the range. I have already calculated the range. I think it is 240 meters. I'm not doing the calculation because the value of range is not important for the solution of this question. Still, to draw the diagram and to get an idea of where the wall is present, you can calculate the range. Then you will see that the wall is present at this distance, 80 meters. Right. So this is the distance where the wall is kept, and now it is said that when it collides, it it rebounds back, and suppose it hits like this. I am not drawing the diagram to scale, and after that it rebounds again and it hits like this, and we need to find this distance. This is the required distance that is being asked in our question. Now what I will do is see when the particle is going from here to here, let it take a time t1, and if I assume that the wall was not present, then the time that it would take here is t2. Right. Now if you observe one thing very carefully, due to the presence of wall, the component of velocity along y direction, if this is x, if this is y and this is x, the component of velocity along y direction does not change due to the presence of the wall. So when we are analyzing the motion along the y-axis, the presence of the wall makes no difference, right? So if the part that I am highlighting again, if this part, okay, let me highlight it with some another color. If this part in orange, if the time taken to travel this part is t2, then the time taken to travel this part, which I am highlighting now, is also t2. So the time taken to travel this part will also be t2. I hope that makes sense. Now see what is the component of velocity along x-axis. If you calculate the component of velocity along x-axis, it will be 40 meter per second, right? Cos 37 degree 4 by 5, so 40 meter per second. Now before collision, the velocity was 40 meter per second. And what will be the velocity after collision? See, it is written that the component of velocity normal to the surface becomes half after each collision. So coefficient of restitution is half. So after the collision, the velocity is becoming 20 meter per second. 20 meter per second. So what is this distance? That is 20 times t2. Why? Because along the x-axis the particle is going as it seem to be moving in uniform motion. There is no acceleration along x-axis. So the component of velocity along x-axis remains unchanged after this collision. So 20 meter per second times the time t2. I hope that makes sense. Now what was the initial velocity along y-axis? 30 meter per second, right? So consider the motion along y-axis. It will be moving like this. So when it comes down, what will be the velocity along y-axis? Same, 30 meter per second, since there is no air resistance. Initially it was 30 meter per second, and after returning back it will again be 30 meter per second, but in the opposite direction. Now it is said that the coefficient of restitution is half, that is velocity is becoming half. As the velocity is becoming half, so after rebounding, what will be the velocity? 15 meter per second after rebounding, right? Now the velocity along x direction is unchanged, right? The velocity along x direction is unchanged. So what will be this distance? 20 times the time I am telling as t, the time taken to travel this path from here to here, let the time be t. Now one thing that we know, that is t1 plus t2 equal to, analyze the motion along y-axis, 2 uy divided by g. What is that? 2 times 30 divided by 10, that is 6 seconds, right? Now see the velocity here, it is when the velocity is changing from 30 to 15, that is velocity is becoming half, so time taken will also be half. So t will be 6 divided by 2, that is 3 seconds. Now one more thing, see that the 40 times t1, when it is before it strikes the wall, it takes time t1. So and the velocity along x-axis was 40, so 40 times t1 equal to 80. That implies t1 equal to 2 seconds. If t1, sorry I wrote it wrong, t1 equal to 2 seconds. If t1 is 2 seconds, what will be t2? T2's value will be 4 seconds, right? Now we know what is d. D is 20 t2 plus 20 t, that is equal to 20 times 4 plus 20 times 3, so equal to 20 times 7 equal to 140 meter, and this is our required answer for this question.